Lesson 7, Complex Number Representation. Section 7.1, Complex Number System. This section reviews this system. Z is a complex number. J is the imaginary unit. Electric circuit theory uses J instead of I, to denote the imaginary unit to avoid confusion with the symbol for current I. A and B are real numbers. A is called the real part, and B is called the imaginary part. A complex number is plotted on the complex plane. The horizontal axis is called the real axis, and the vertical axis is called the imaginary axis. The real part A is plotted on the real axis, and the imaginary part B is plotted on the imaginary axis. Z equals A plus JB is plotted as shown in this figure. The magnitude of Z equals square root of A squared plus B squared. The angle of Z, denoted by phi, is positive in the counterclockwise direction. Cosine phi equals A over the magnitude of Z. And sine phi equals B over the magnitude of Z. By using the magnitude and the angle of Z, the complex number Z can be represented as the magnitude of Z, times cosine phi plus J sine phi. This form is called the polar form. This equation is numbered 7.1. If Z1 and Z2 are given in polar form, the addition of Z1 and Z2 involves adding each part separately. The magnitude of Z1 plus Z2 is given by the square root of the sum of the squares of the real part and the imaginary part. Using this magnitude, the right-hand side term can be transformed as shown in this equation. Then, the summation of Z1 and Z2 can be reformulated in another polar form. This equation is numbered 7.2. The definitions of cosine phi 1 plus 2 and sine phi 1 plus 2 are given below. This figure shows the addition of Z1 and Z2 in polar form. Z1 plus Z2 becomes the diagonal line of the parallelogram formed by Z1 and Z2. If Z1 and Z2 are given in polar form, then the multiplication of Z1 and Z2 can be expanded as shown in this equation. By applying these trigonometric formulas, Z1 times Z2 is transformed into this polar form. This equation is numbered 7.3. This figure shows the multiplication of Z1 and Z2 in polar form. The magnitude becomes the magnitude of Z1 times the magnitude of Z2. The angle becomes phi 1 plus phi 2. The division of Z2 by Z1 is performed by rationalizing the denominator with the complex conjugate. That is to multiply the complex conjugate of the denominator to both the numerator and the denominator. Then the numerator and the denominator are expanded. And, by applying these trigonometric formulas, division of Z2 by Z1 is obtained as shown this equation. This equation is numbered 7.4. This figure shows the division of Z2 by Z1 in the complex plane. The magnitude becomes the magnitude of Z2 over the magnitude of Z1. And the angle becomes phi 2 minus phi 1. Exercise 7.1. This is your homework. Pause the video, and write the answers. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.